Let us look at proposition number 87 of book 10 of Euclid's Elements. The proposition says to find the third apotome. So we have already seen how to find a first apotome and a second apotome. And here we will look at the third apotome. Set out a rational straight line A. Set out three numbers E, B, C, and C, D such that they do not have a ratio equal to number square is to number square with one another. BC is to BD is equal to number square is to number square. So what this means is E is to BC is not number square is to number square. E is to CD is not number square is to number square. And BC is to CD is not equal to number square is to number square. But BC is to BD is equal to number square is to number square. Find FG such that E is to BC is equal to A square is to FG square. So using this proportionality, we find FG. Next, we find GH such that BC is to CD is equal to FG square is to GH square. A square is to FG square is equal to number is to number. A square is to FG square is equal to E is to BC, which are two numbers. That is E is to BC, which implies A square is commensurable with FG square. Since A square is rational, FG square is also rational, which implies FG is rational. Now, E is to BC is not equal to number square is to number square, which implies A square is to FG square is not equal to number square is to number square, which means A is incommensurable in length with FG. FG square is to GH square is equal to number is to number, that is BC is to CD, which implies FG square is commensurable with GH square. But FG square is rational, so GH square is rational, which implies GH is rational. And BC is to CD is not equal to number square is to number square, which implies FG square is to GH square is not equal to number square is to number square. So FG is incommensurable in length with GH. So we have shown A is incommensurable in length with FG. FG is incommensurable in length with GH. FG and GH are rational straight lines commensurable in square only because they are incommensurable in length. So therefore, FH is an apotome. Now, E is to BC is equal to A square is to FG square, and BC is to CD is equal to FG square is to GH square, which we can combine it in this form. E is to BC is to CD. E is to BC is to CD is equal to A square is to FG square is to GH square. So X equally E is to CD is equal to A square is to GH square. E is to CD is not equal to number square is to number square, which means A square is to GH square is also not equal to number square is to number square. So that means A is incommensurable in length with GH. So FG and GH are incommensurable in length with A set out. We find K such that FG square is greater than GH square by K square. And since BC is to CD is equal to FG square is to GH square, in conversion, BC is to BD is equal to FG square is to K square. BC is to BD is equal to number square is to number square, which implies FG square is to K square is equal to number square is to number square. So which means FG is commensurable in length with K. So what have we shown till now? We have shown that FG square is greater than GH square by K square, where K is commensurable with FG. And FG and GH are incommensurable in length with A set out. And this, as per definition, is the third apotome. That is FG minus GH. That is FH is a third apotome. So we have found the required third apotome. So that is proposition number 87 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.